following example will determine when an oxidation reaction can occur. Okay, so the example is that basically will an aqueous solution of iron 3 chloride oxidize magnesium metal. If so, write the balanced molecular and net ionic equation for the reaction. So the reactants are going to be iron chloride and magnesium. These are going to be the reactants. So we are given two substances, the iron chloride, that is this one, and the metal, magnesium, and as if they react each other, so in a way that will produce an oxidation reduction reaction. So a reaction occurs if the reactant that is a metal in its elemental form, that in this case is magnesium, is located above the reactant that is a metal in its oxidation form, that is going to be iron, and the table of the oxidation half oxidation reaction. Half oxidation reaction. Okay, so if in that table the magnesium is above of the metal of this reactant that's going to be iron, then that reaction could occur. Then in that way, the iron chloride could oxidize magnesium. If the reaction occurs, the iron from iron chloride is reduced to iron, and magnesium will be oxidized to magnesium plus 2. Because magnesium is above iron in the table, the reaction occurs. To write the formula for the salt produced in the reaction, we must remember the charges on ion commons. Magnesium is going to be always plus 2, while chloride is going to be minus 1. So that means that we're going to need two chlorine in a way that cancel the plus 2 of magnesium, and this will be the salt produced in this reaction. So the molecular equation will be iron chloride plus a metal, okay, producing the magnesium chloride plus the iron as a solid, because remember that this iron was reduced. In that way, when it's reduced, you will produce the metal itself. So both of them, the salts and the reactants and the products, are soluble strong electrolyte. So we can write the ionic form of each to establish the net ionic equation. So that will be magnesium, and we can cancel the chloride because they are basically the spectator ion. Okay, so we cancel this one, the chlorine, and we will have magnesium solid plus the iron plus 2, producing the magnesium plus 2 plus the iron as a solid. So in this way, we can see here the magnesium, the oxidation number of magnesium that here we have in an elemental state is going to be 0. And it turns from 0 to plus 2. So the oxidation number increased. So that means that the magnesium was oxidized. While iron went from plus 2 to 0. The oxidation number of iron here, that is in an elemental state, is going to be 0. So it went from plus 2 to 0. That's the reduction. Okay, so we can see here that we have the half reaction of the oxidation by magnesium and the half reaction of the reduction by iron.